requirements to process mapping is extremely important. And the reason I mention this is when you get into a transformation project, the first thing you want to ask your sponsor bank or the bank that is asking you to do this transformation testing is for process-based documents which map to requirements. Guess what happens when I have a defect and there is no requirement I can attach the defect to? Do you think any vendor is going to allow me to raise a defect without a requirement? Exactly. And so I will get into these ambiguous situations where they say, oh, I built the software to spec, but it doesn't meet my business objectives. My transformation objectives are out of the window. And so it's important to have that traceability because now you can trace your test cases to a requirement, which then guarantees you that your defect will get resolved and that you will have a vendor to go to. And so that becomes an important aspect of having these checkpoints along the way within your software development lifecycle. The other challenge when you have so many different vendors, 20 plus vendors working in the same equation, in the same landscape. I used to be a developer. People talked about what's your career, et cetera, et cetera. I used to be a developer before I came to testing, so I will start off with that confession. And so it's fun to be having from a development world come into testing because now you get to critique other people's code and not have to worry about critiquing or someone critiquing your code. But part of that fun is also watching yourself being in situations where you have 20 developer teams, each of which is faced with a defect where an end-to-end workflow doesn't work, right? So when the end-to-end workflow doesn't work, you start off with the application that is most culpable. And you would say, you know, OEM vendor 1, this is your problem. And guess what happens? The blame fingers start pointing at each other. And sure enough, it's nobody's problem except QA's problem, right? All the software is perfect. It doesn't work end-to-end. But the only team that is to blame is QA because everybody else has done their job, right? So how do you resolve that? You resolve that by getting everybody on the same page with your end-to-end scenarios. So you get everybody, all the 20 plus OEMs plus whoever is the SI into the same room and say, when you finish your coding, I'm going to subject this code to these scenarios which are end-to-end. And the expectation is it is going to work. And everyone would have to, you know, agree to the fact that, yes, this is what they all expect the system behavior to be. If you don't get that consensus early on in the software test lifecycle, and you wait until development is done and do this in the QA cycle, you get into the heat of arguments where everyone is trying to, you know, pass on the buck as far as whose defect it should be. And the more the number of vendors, the more the number of development teams, the more the number of issues that you will have in these types of transformations. Choosing the QA period of the software test lifecycle, because this is really wasted time, because there's going to be heated arguments and a lot of debates at that point in time. And so you completely eliminate that by having these shared UAT plans with them up front. Right? The other challenge that comes up is, you know, when you do a transformation, you're obviously migrating your data from the old system to the new systems, right? It's some to many, a few to many, right? How do you test it? Do you test it with the real data, or do you test it clean? Do you test it with what we call as manifested data, or do you test it with the migrated data? So what happens if you try to test it with the migrated data from day one, and there are problems in the software? Developers find an easy route out by saying, oh, it's a data migration issue. That data is not consistent, and therefore it's a data problem. If you had started with a clean system, you would not get this issue. And so to eliminate that noise, when we plan our test rounds, we start off with one round with clean system with no data from production, pure data created from the systems that are part of this transformation. Eliminates all the noise, all the issues with whose problem is it. And so manifested data is your first initial round of testing. You could start off with requirements-based testing and ensure that all the requirements, when looked in isolation, work. And then you get into your next round of testing, which you plan for doing the same set of tests, but this time with migrated data. Okay, so there are opportunities for automation because you're now repeating your efforts, but in the migrated case. You don't do everything. You can cherry pick and figure out what makes most sense to retest with migrated data. So when you get into this next round, you can certainly do process-based testing in conjunction with the migrated data. So you do have two variables at play. One is your process may fail, or you may have an issue with migrated data. Right? But because you've tested in the clean environment, you can repeat your requirements-based test anytime a process fails and figure out, is it a code issue or is it an end-to-end process issue? Go ahead. Because especially of the ones that I intend to rerun in my round 2, because I know that the workflow will stay the same, the screens are the same, so automation is enabled, but the data I will use is going to be production data. So I would use automation as much as possible. If you've done your framework, we'll talk about automation a little bit, but if you've done your framework correctly, you designed it so it can pick production data and work with it, then you should not have issues during the second round with that specific code if it is stable. So that strategy allows you to eliminate noise associated with migrated data, eliminate noise associated with process-based testing. Remember that traceability is the first prerequisite I said you need to have in order to prevent QA from getting to be the policeman on the dev street, right? So you don't want to be that police cop because it's a no-win business, right? You just end up being coordinator for 20 development teams. Right? So, yeah, go ahead, please.
The existing data. So it's a good approach, but don't you think it will increase the overall cost first?
Yes, if you look at it purely from mathematical perspectives, but if you actually put into a real live, world example, you will find that you get into these situations of arbitration where nobody proceeds, and you will have to probably take a step back and then retry some of this scenario in a different way. So practical experience is that it actually doesn't add cost because it cuts out the confusion. So just to give you a flavor, no banking transformation happens with one round of testing. And typically, you will need at least 3 to 4, maybe more rounds of testing before you get to the end state. Right? So it's perfectly okay. It's not increasing your actual cost or effort to do it in a structured fashion that allows you to eliminate possibilities and ambiguities. Correct. Already invested in its legacy applications and has been, set in its ways of doing work. How long does it take to do a transformation? So typically, I would put it in the time frame of 2 to 2.5, 3 years before you end this entire process of transformation. Do a disruptive transformation and throw everything out of the window when you can adapt your systems to progressively add on software. And so it all depends on your starting point. If I start off with a nano, for lack of a better example, and try to say I'm going to start throwing parts in and make it a Mercedes-Benz by the end of, and no offense to any car company, I'm just giving you this as an example. A small car, for a certain target consumer, and try to transform it to a different target base. Want to take the seats out, put leather seats, take the whole engine out and try to put, it doesn't work because at some point the limitation is your starting point, right? I'm just giving that as a visual. It doesn't work because the limitation is your starting point. That's when you have to throw out the window. If you are lucky enough, like you were asking, why is it that I should do this? Because 3 years later, something else will arrive which will render this whole effort meaningless. Right? But what you're doing is you are now taking that nano, small car, and going into a E-Class Mercedes, okay, just using that example, and saying, okay, if I need to upgrade, I still have a lot of flexibility in this particular frame to do new things to this car, as opposed to trying to keep building on my old investment and try to catch up with today. So it all depends on your starting point. You may be able to do add-on, but typically if you've never transformed, then sometime you have to bite the bullet and transform. And then you might be able to do incremental. And they tried to build all the connectors to the previous legacy. In some instances, it was not possible. And in some instances, it would have become more expensive. So the best cost-effective solution was to do a transformation in this test life cycle. Because every OEM has to, and you should be, interested in knowing what they have done as a part of their SIT. Okay? Do not take a hands-off approach. Because what happens is when you take a hands-off approach and let them give you and then you'll figure it out whether it works or not, is you get into messy situations where you can't pinpoint who is at fault. And so just like I mentioned, it is important to get your UAT scenarios or your end-to-end test cases reviewed by your development peers. Ask them to do the reverse. Have them share their SIT test cases with you. And look for some real deep unit testing and integration testing in what they do, specific to the data combinations that would traverse the pipe that connects these applications through the customization. And see if they are actually doing something serious or they're just doing something cursory to give you code as quickly as they can. In fact, if you have the ability to influence your banking partner or the client, then put in penalty clauses for defect quality into their contract. If you have arrived early in the scene, before and with the other OEMs in the picture, ensure you put in these types of clauses within their contract that there would be a certain defect injection rate or a quality of their code handed off to you. If you don't, then unfortunately the program will get pushed in different directions based upon a vendor's commitment to quality, the size of the vendor, because when you talk about the banking space, you have vendors that are 200-person companies, and then you have the large giants with 20,000 employees. So turning around a defect is different for different vendors. So some SLAs along with the contract, that go with the contract, that say, I would expect a defect to be fixed within X hours or days, would be beneficial to this process if this was part of the SLA agreement with the OEM itself. So the question is, by putting in penalty clauses, you're kind of pushing them to the edge where they start, if everyone's holding a gun, then everyone is basically being cautious and overly cautious is the example. And so the idea is not to give everybody a gun, right? The idea is to give everybody a clear understanding of what gets them into court, right? Without giving everybody a gun. So that says, I'm not going to penalize you or charge you, but don't release your code until you met these objectives. And when I put out a defect, you are going to fix this defect in these types of circumstances. Otherwise, I may not pay you, not in a negative sense where I will penalize you, but your deliverable is not considered done until this code has met with this level of quality and your SLAs have been met. And so that would be not necessarily a ding, but it affects their accounts receivable. So a lot of vendors will be very careful and cautious. And it will be on the dashboard of the CTO of that company. Right? So that helps. But I agree with you, you don't want to push it to the point where it becomes painful that someone is paying the bank or your client money because of their code quality, and then becomes contentious and people start taking positions. So these are things that you want to actually have defined. Because you have defined your end-to-end processes, you socialized everything with your development partners, defect prioritization becomes easy. Everyone is on the same page. When I run this process, if it fails, it's a Sev1. If I run this process and it fails, it's a Sev2. This clarity needs to come out in your plan up front. Because if you don't have that clarity, then you get to QA street, that defect goes into this, because of the SLA, because you say, hey, Sev1, this means 1 day turnaround. Sev2, you have to do it in 3 days. Now it gets kicked around as, oh, is this a Sev1 or a Sev2? I think it's a Sev2. No, it's a Sev1. No, it's a Sev3. All of that clarity, what constitutes a Sev1, what constitutes Sev2, happens up front before development. And that is a fair way of doing it, because when they are coding, they know how they will be graded. Right? So the scorecard is obvious to them before they get into the dev cycle. They know what you're going to hold them accountable